Since the release of Z-Image Turbo ControlNet 2.0, we have always had one lingering regret. The local inpainting function was not implemented in the official ComfyUI, but today ComfyUI submitted a new version, and it has now implemented the basic inpaint functionality. Now, let's take a look. What you are seeing now is the official ComfyUI website. You can click on this submission list. We can see this piece of information. ControlNet's inpaint function has now been realized. However, we will be using a specific node. This node is called Z-Image ControlNet. This node is different from the one we previously used with ControlNet 2. Therefore, it is an entirely new node. For its detailed information, you can click the number next to it. Look, this node has three very important inputs. The first one is our control image, such as our pose map or outline map. The second one is the original image that we are going to repaint. The third is our mask. Below that, there are some workflows. I reviewed them, and essentially, there are no major issues. Next, we will demonstrate this inpaint function. Let's see what the actual effect is like. I have also built a workflow on Runninghub. Everyone can access this platform through Runninghub in the ComfyUI field. Runninghub is an excellent online workbench. This is because whenever new technologies or extensions appear, they follow up immediately. You can register for Runninghub using the invitation link in the video description, which will grant you 1,000 free points. Additionally, you will receive 100 bonus points simply by logging into Runninghub daily. This allows you to try out your own workflows. Now, let's look at this specific workflow. This workflow is actually similar to the ControlNet 2 workflow that we previously discussed. But please note, this workflow was actually built by me. This is because we currently cannot see the workflow provided by the official source, whether it be on their settings page, in their official documentation, or even on their blog. We haven't seen the officially provided workflow yet, therefore, you can use my workflow as a reference. Later, once the official workflow is released, everyone should use that one as a standard. Regardless, the results achieved by this workflow are still quite good. Next, let's briefly analyze this workflow. First, we need an image for repainting. The only thing you need to pay attention to when using this image is the resolution. Do not choose an image with too low a resolution. This is because when we are repainting, we still need a certain number of pixels as a base. If your image for repainting is too small, the quality cannot be guaranteed. Just like with our other local inpainting workflows, we need to draw a mask. You can right-click to open the mask editor. My main goal now is to put glasses on this character, so I have drawn a mask over the eye area. Next is our model loading. First, we load the Z-Image Turbo main model. This one was a LoRa that I trained previously, but I am skipping it now. Then our shift value is set to 3.0. Here, we must load the 2.0 version of ControlNet. This is our text encoder and VAE. Now, here comes the most important node in this workflow. This node is new with this update. Therefore, it is different from the node we used before. We previously used a different node to add ControlNet to our model. This time, they switched to a dedicated node called Z-Image ControlNet. The model input here is of course our Z-Image main model. The model patch is the ControlNet 2 model that we loaded. I want to emphasize something here, as many fans left comments saying they couldn't find the model here. You should note, although this is called ControlNet, it is loaded into the main model in the form of a model patch. Therefore, you need to download this model, and the directory where you place it is not inside the ControlNet folder. It is inside models, and then there's a directory. This directory is called model patches. You just need to open it and place the file inside. Similar models we have used before include USO, which is the style transfer model. So please pay attention to where this model is stored. Moving down, the next input is the image. This image input should actually be connected to our pose map or outline map. Since our current workflow is testing Inpainting, I did not connect it here. Below that, Inpaint image and mask are the image and mask from the original picture that we just discussed. After that, I added a node. We might not have used this node for a long time. We often use this node in previous Inpainting workflows for Flux, South Dakota XL, and even SD 1.5. The main function of this node is to give the model pixel level drawing capability. To ensure the final inpainting quality, I included this node. The prompt below should still be written according to the overall composition. For example, what I wrote now is a beautiful Western woman and wearing glasses. Further down is our latent. For the latent, everyone should try to keep it consistent with the original image since you are performing local inpainting. There are two methods for generating the latent, and this is one of them. Of course, there is another way to do this. You can take the image and perform a direct VAE encode. Using this as the latent image is also acceptable. Since my denoising strength is set to 1.0, the result will be fine regardless of which method you choose. Likewise, I am currently using 8 sampling steps and a CFG of 1.0. The sampler is set to Euler and the scheduler is simple. Here, we have a slight difference compared to the previous workflow. Previously, to improve the generation results, we used dual samplers, which looked a bit like the WAN 2.2 sampler, but here we only used one. This was a basic judgment I made based on the generation results. I determined that the difference was not significant, so there was no need to split it into 2 samplers. After that is the decoding, which generates the image we need. Take a look. The result after adding the glasses is quite good. Now, let's run it once, take a look. Notice that the style of the glasses changed somewhat. Since our seed here is random, each generation will be different. Let's try switching it to this latent. Let's see the effect. Feel it out. There isn't actually a huge difference. So, you can use either of the 2 methods. The area we are currently drawing in is relatively small. Next, let's enlarge this repainting area a bit. Right-click to open the mask editor. Then we select the mask tool. We'll color the hair. Then we save it. Now we clearly specify in the prompt to change her hair color to blue. Let's run it now. Take a look. This result is also good. It didn't turn her hair into a very noticeable blue. Instead, it added blue elements based on the original hair color. I think this also looks very good. Next, let's expand the repainting area even further. Now, I will paint the entire figure. Then we save it. For the prompt, I will directly change Western beauty to Eastern beauty. Let's run it to see the final result. As you can see, the character has changed. The overall inpainting effect is also very good. So through these few examples, we have briefly tested the inpaint functionality of ControlNet 2.0. Personally, I think it is quite good. Of course, some people might wonder if it is possible to use a pose image and then use inpainting, thereby having both pose guidance and local repainting simultaneously. I advise everyone not to do this. The more content you try to control, especially if the proportion between your pose map and your inpainting image cannot be optimally managed, the resulting effect may not be guaranteed. If you absolutely need both, I suggest doing it step by step. You can generate first and then repaint. Try to avoid doing them together. Alright, that is all for today. Follow me and become someone who understands AI.